Right, today we're going to be looking at fractions of an amount. Let's start with a recap of what we did in the last video. So in the last video we had a look at representations of fractions that looked, well, one of them looked like this, if you like, a pizza. And in this pizza we could see that it was split into 8 pieces. We can count them 1, 2, 3, 4, 5, 6, 7, 8, and 3 were shaded in. So we could write that as a fraction, saying that there are 8 pieces altogether, but we are only looking at the 3 shaded in. Or we could say we're eating 3. And we could do calculations with that. We could say, well, what's 3 pieces of 8 plus, well, let's have a look at this pizza. Let's check there are 8 pieces in total. 1, 2, 3, 4, 5, 6, 7, 8. Yep. Plus 2 pieces of 8. And we looked at putting that into a bar model. So I'm going to draw my bar, and it's not very straight. Let's see if I can make this better. If we split it into 2, we split that into 2, and we split those into 2, and the reason for that was to get a bar that had 8 pieces in it, because we're splitting our bar into 8. 1, 2, 3, 4, 5, 6, 7, 8, and then we could say, yep, we're taking 3 of those pieces of 8, and we're going to take another 2 of those pieces of 8. So altogether we have 1, 2, 3, 4, 5 pieces of 8. So our answer would be 5 over 8. And some of you may have spotted that that's the same as adding up the numerators and keeping the denominator the same, because that's just how many pieces we've split our whole into. We could go a step further than that. We didn't look at this last week, but you could also do a subtraction problem. This is meant to be a minus sign, using the bar method. So first let's write it as a fraction. This is our pizza. It's not split into 8 pieces this time. If you count them, it's actually split into 1, 2, 3, 4, 5, 6. So it'll be a 6 as our denominator. And what's our numerator? Well, if we look at the shaded pieces, it's 1, 2, 3, 4. And we'll just write the operation sign here. Minus, what's our fraction here? Well, yep, it's split into 6 again. So the denominator 6. And there's 2 pieces shaded in this time. So this is our question as a fraction, 4/6 minus 2/6. And we could do that as a bar model. I'm just going to draw a bar. And now we've got to split it into 6. Harder than splitting into 8, because we can't just keep halving. We can halve it, so now we've split it into 2 halves, but we need 6. So I'm going to have to split these boxes into 3. It's about there, I think, and about there. Let's double check we've got 6. 1, 2, 3, 4, 5, 6, and they're pretty much the same size. So let's imagine now we start with 4. So we start with 4/6, and then we take away 2 of those 6. So we've got 4 here. Now imagine we're going to take away 2 of those 6. So we had 4, 1, 2, 3, 4. We take away 2 of them, because that's what this is saying, take away 2 of them. Take away 2 of those 6s. How many do we have left? We've got 2 left. Just these 2 here. So we now know that 4/6 minus 2/6 equals 2/6. And again, you might notice that we could do that just by subtracting the numerator. So taking 2 away from 4 and keeping the denominator the same. But I think it's better to show it, and you can kind of see how it works as a picture. Right, if you are not sure about any of this, then go back to the last video. And if you can't find it on the blog, just go to the search box on the side, type in maths, and it should come up with all the videos I've done. So if you're not sure about how any of this works, go back to the last video. If you are sure, then we can move on to something that's a bit more challenging, which is looking at fractions of an amount. So we've just been looking at fractions of a whole. So we've been looking at 3/4 of a pizza. So we can easily show that as a picture, split it into quarters, 4 parts, shade in 3, and that's a whole pizza. What if instead of looking at a whole pizza, we looked at 3/4 of, say, 12 sweets? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So instead of a whole, we're looking at a fraction of 12. There's 12 sweets there. So the fraction still works. We can still sort of say, well, this is what we're looking at. Similar to this, it's this much, it's this much. But how do we actually work out what 3/4 of 12 is? It's not a whole anymore. How can we use a bar chart to show us that? Well, we're going to have to draw a bar chart that shows 12 instead of just a whole. And this is where squared paper does come in really useful, because it helps us to draw a bar that's 12 long. And I'm going to do that now, and hopefully we can see how this is going to help us. So I'm going to start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'll just turn that into a bar. So that's a bar that's 12. It represents 12 sweets. Each one of those squares is a little sweet. But I want to find 3/4 of them. So I need to split my bar into how many pieces? Well, 4. Our denominator shows that we're splitting our 12 into 4 pieces. Well, I can do that. I've done it on the bar before. I just need to halve it and halve it again. I think the half, you've got to be exactly right about this. I think it's there. Let's just check. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yep, 6 squares in each. And then we can split that again. It's a bit easier because they're smaller now. So I've split my bar now into 4 pieces, which is good because our denominator is 4. And I want 3 of them. 1, 2, 3. So to find out what 3/4 of 12 is, I just have to count the total number of sweets or squares I've shaded in. So 1 square was 1 sweet. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. I have got 9 sweets. So if I have 3/4 of 12, the answer is 9. So I can write it down here. 3/4 of 12 equals 9. And I can show that by drawing a bar that's 12 long, splitting into 4 equal parts, and taking 3 of those parts and counting how many sweets those 3 parts cover. And you can kind of see how that works with my drawing here, but of course in my drawing, because I already knew the answer, I made sure that I only kept 3 sweets out. You wouldn't be able to do that normally and get it right. Use the bar method. Let's try one more before you do a couple. So 1/4 of 12. So again, 1/4 of 12, imagine you've got 12 sweets. And we want 1/4 of them, so it's going to be something like that. I don't know if that's right, but we're looking at this bit here and not these bits. Let's work out the exact answer using the bar model. So because it's 12, I'm going to draw a bar that's 12 long. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Turn that into a bar. And I'm going to have to split this bar into how many pieces? Well, my denominator is 4, so I'm going to split it into 4. And now I could do it by sight and counting squares, I could do it a different way as well. I could say, how many times can I take 4 out of 12? And if you know your times table, the answer is 3. So I can just count 3 squares. 1, 2, 3, 1, 2, 3, 1, 2, 3. So 4 divided by 12 is 3. That saves me having to guess where the lines are, which is good for bigger numbers. It's harder for bigger numbers. But there we go, I've split it into 4 pieces, and now I just want 1/4. The last one was 3/4, this one's just 1. So I'm just going to shade in 1. And remember, 1 square equaled 1 sweet. So let's see how many sweets I get if I just get 1/4 of 12. I get 1 sweet, 2, and I get 3 sweets. So 1/4 of 12 equals 3. Right, I've got a couple for you to do. Should we do one at a time? Okay, so ignore this top bit here. You can pause the video and have a go at doing this. I've drawn the bar for you. If you've got graph paper or squared paper, that's really good. If not, maybe you could use a ruler, or maybe you could just draw squares. Okay, so the question is 2/4. Remember, if it's a 4, it's not 2/4. We say 2/4 of 8. I've drawn a bar that's 8 long, and I want to split it into 4 pieces. I'm just going to split it in half and half again. It's 4 pieces, and I want to look at 2 of those pieces. So I'm going to shade in 2 of them, and let's count how many of those squares we get if we shade in 2 of the quarters. We get 1, 2, 3, 4. So 2/4 of 8 equals 4. Give yourself a big tick if you got that right. Okay, harder one now. And we've got 3/4 of 16. All right, pause the video and have a go at this. Right, okay, so I hope you've all drawn a bar that's 16 long. It's longer, it's harder to get right, and you've got to be accurate. And now we're going to have to split this bar, which is 16 long, into 4 equal pieces. So I could sort of just try and work it out by sight where those lines are going to be, or I could divide 16 by 4. Now I know 4 times 4 equals 16, so if I do the inverse, 16 divided by 4 equals 4. So let's have a look. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So now I've got 4 equal pieces on my bar, and I want 3 of those pieces. So I want all of that one, all of that one, and all of that one. But let's count how many squares I get if I take 3/4 of it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 3/4 of 16 will get me 12. Okay, thanks for watching.